is a really good laboratory to go out and test these kinds of hypotheses in real life.
That's right.
So that's what we're looking for on the moon.
So we just hiked up the slopes of the Hekla volcano in southwest Iceland.
We have a team of over 30 scientists here who are exploring the amazing terrains of Iceland.
Scientists are actually able to put their boots on the ground to touch the material that's similar in the field, interpret it and take that back and then compare it to the remote sensing data that we look at every single day.
By kind of truly understanding how processes work here on Earth, we can extrapolate that to how it might be on Mars or the Moon.
And I think you'll have a better grasp of the processes that are going on those planets as a result. This particular site is important for lunar research. The regolith on the lunar surface is pretty fluffy, and we think there could be small grains of water ice hosted within that. And so it's important to find a deposit on Earth that might be more analogous. And that's the big challenge that everybody's asking about the moon, is how do you detect that and what geophysical instrumentation is going to be the best to do that.
Like at what depth does that transition to having ice within it that cements all those pumice grains together? And then where does that ice end, at what depth?
So today we have a few of our teammates setting up some ground penetrating radar surveys.
We're gonna do all of these lines this way.
Ground penetrating radar is a surveying technique that uses microwaves to look into the subsurface.
Okay, so that's 10-0, so the x-axis is going across the snow bowl.
Yeah.
And what it does is it makes a 2D slice of the subsurface, and we use that to understand what sort of material we're looking at.
Look at those reflectors.
Oh yeah.
Let's go look at ice grains. We brought in an auger to drill down into the subsurface to confirm our observations.
Auger in the hole.
And then we can confirm by taking these drill cores and then bringing up, a core from the subsurface and seeing where is the pumice.
So that we can actually ground truth the observations that we make with the GPR.
Yeah, and you can see the sparkles of the ice.
That's a gift shop right there.
Yeah.
That's really...
Nothing can mark polar scientists more exciting than ice crystals.
And so the ice is just filling the pores, not actually going in between and cementing it together.
You have to reach some sort of threshold in concentration to actually be able to detect that with the radar.
Down at site 1, so at lower elevation is where you actually have enough ice to cement the pumice.
Ooh, I'm so excited for show and tell.
We have something to show.
I'm geeking out right now about this, actually. And so it's exciting to find it because we can actually start to test that hypothesis here in real life instead of just modeling it.
So we're gonna drill through the snow and look at the transitions from snow to ice to volcanic sediments. We'll get going. Hopefully we'll see some ice cemented volcanic sediments, and then we'll see how deep we can get. We can get down to at least 3 meters with this ice auger. Yeah! Yes!
Yes! And so a lot of the ice as we move through here has different characteristics. Some of them are just filling tiny pores, some of them are actually cementing it, and we're not sure what the ice on the moon looks like. As they look for ice underneath the surface, what I am trying to do is learn to characterize that ice and do that using visible imagery like cameras. So this is the Nikon Z9 camera that the astronauts are going to have on Artemis 3. To be able to see within the individual grains of rocks. And it's just not a pretty picture, it's a piece of data. And so trying to study how these different types of ice respond to imagery and how best to capture them to help learn how we can prepare our astronauts in the future.
Thinking about future sustained human presence on the lunar surface, there could be opportunities to use radar to help scout for these types of deposits.
If you are sending astronauts, right, like you want to know, is 1% of the ground ice? Is it 5%? Is it 50%?
Yeah.
Is it 100%? And like being able to distinguish those different ranges is going to be crucial.
I'm just really excited about the prospect of doing actual geology on the surface of the moon and as we work our way toward Mars.
I am so excited to help the next mission to the moon. So it's really a dream come true, and I can't believe I'm actually going to be a part of it. And so I'm so excited.